Hi. Do you ever find yourself wondering, what the hell is going on? You're not alone. This thing that we call the human experience, a patchwork of unsettling experiences, needs, desires, all that crap, is really confusing. I don't plan on getting all poetic here, that's not really my custom. But if you think about it, the human experience is kind of poetic in its own weird way. Unpredictable, awe inspiring, mysterious. It being so is kind of a culmination of what we make human history out to be: unpredictable, awe inspiring, mysterious. All that being said, I think it's important that we take a look back to our real roots, back to where it all began, to answer the question, why are humans so weird? Alrighty, so first I think it's important that we take a basic look at how evolution works. In the most basic definition, evolution is changes in allele frequencies in a population over several generations. An allele is an alternative version of a gene caused by genetic mutation. This plays into the concept of natural selection, which is essentially a way for nature to filter out the trash. For example, our two frog friends, Greg and Fred, live in the forest. Greg is like the rest of the population and has green skin to blend in with the leaves and the trees. But some dickhead humans cut down his home. So now Greg's green skin is now a disadvantage because he has to live on the brown and black dirt, and is now very visual to predators along with the rest of his frog people. But luckily for Fred, he was born with a genetic mutation in the gene's coding for skin color, and his skin is a lot darker than the rest of his clan. This would usually be a detriment for him, but his environment had changed to favor darker skin to blend in easier. So now he is more likely to survive long enough to mate and pass along his mutation of darker skin than his counterparts. And so over time it is likely that we will see this frog population have darker skin, as it is now crucial for their survival. And those born with lighter skin are not likely to survive. Natural selection is essentially the driving force of evolution, along with things like gene flow and genetic drift. Mutation creates variation, which is then acted upon by natural selection. Evolution is really cool, huh? It is. You know it. Now that we have that out of the way, have you ever seen this image? Ah, yes, the Zallinger projection. Simple, concise. Tells you all you need to know about human evolution. I could end the video here, except no, I'm just kidding. This projection makes 0 sense. Let's look at a more accurate image. There we go. A common misunderstanding about evolution is that it is just a straight line getting more sophisticated over time. But evolution of species is more like a jumbled bush which branches out over time, each branch ending and beginning at different times. This information is mostly based on our fossil evidence as well as other methods of dating. Now, it may seem like subspecies just appear and vanish suddenly, which may seem like patterns reminiscent of creation, which it's not. Shut up, nerd. This model is called a cladogram, and you'll likely know it as a family tree. There are many different kinds of models for measuring this kind of thing, some more complicated than others, but we're just going to stick with the family tree because it is the most understandable model. Alright, let's take a look at our family tree. Just for fun, I made it a real tree, so subscribe for that. Each branch that skews off from the main trunk represents a group of human ancestors. You may be wondering where other apes and monkeys like chimpanzees are on this tree. Well, they aren't. We shared a common ancestor with chimpanzees around 6 to 8 million years ago, although we aren't exactly quite sure where we branched off with them yet. Because of this, we aren't actually directly genetically related to other apes like chimps, gorillas, orangutans, and bonobos. A lot of people wonder why there are still other apes around if we evolved from them. Well, it's because they evolved alongside us. We simply branched off from them sometime in the past. Think of them as those kind of odd cousins that you see at those biannual family reunions. Anyways, here's our immediate family. We have 4 different branches on this tree, containing the Ardipithecus group, the Australopithecus group, the Paranthropus group, and the Homo group, which we belong to. The Ardipithecus group is our closest ancestors to other apes, the first known genus in the Hominidae family. They evolved in Africa and were likely the first of our ancestors to develop basic upright walking, and are thought to be direct ancestors to the Australopithecines. The Australopithecus group were the first group to walk upright regularly. They are an interesting crossroads between other apes and humans, as they had human-like traits, such as bipedalism, but also had smaller brains like other apes. The Paranthropus group isn't really related to us directly, they branched off from us a long time ago and they're all extinct now. Finally, the Homo group, the one that you probably know best, is the one that we are in. Homo is pretty much the first group that started to specialize in brain size, and because of that, they have been extremely successful. Let's take a look at a few of our family members to get a better understanding. First up, Sahelanthropus chadensis. I didn't show this one initially because this one is a unique case. Sahelanthropus is one of the oldest human ancestors. It lived around 6 to 7 million years ago. It was first reported in 2002 with a nearly complete cranium and fragmentary lower jawbones found in Chad. Sahelanthropus had a combination of ape and human-like features. Like an ape, it had a smaller brain, likely even smaller than modern chimps, as well as large brow ridges, an elongated skull, and a sloping face. Human-like features include smaller canine teeth and a spinal cord opening underneath the brain, while other apes have it in the back of their skull. This is evidence that Sahelanthropus occasionally walked upright. There is very little evidence as to what they ate primarily, but it is suggested from where they lived that they probably had a very fibrous diet, mostly plants and fruits. Alright, next up, let's look at a more well-known example, Australopithecus afarensis. It lived around 3.9 to 2.8 million years ago, and was notable for its evolutionary advancements toward upright walking. They looked like this, pretty familiar, or like this, which is the most terrifying thing I've ever seen in my entire life. Anyways, let's look at some of those adaptations, because they are seriously cool. The pelvis is very broad, while the femur is angled inward, which moves the center of gravity towards the foot. The feet themselves had large arches and soles, and the spine had curvatures that supported upright posture. Comparing it to a modern human skeleton, we can see how similar they are. One last interesting piece of evidence is the fact that the foramen magnum, or the hole that connects your spine and skull, is on the bottom of the skull in afarensis, while in other apes like chimps it is in the back. Alright, lastly, we're going to look at probably the most important player in our human ancestor history, Homo erectus. Don't laugh. It's not that funny. Homo erectus is the first of our ancestors to show truly human proportions, very similar to ours. What separates erectus from the rest of our ancestors that came before it is that it had developed features more suited to living on the ground, unlike other hominids who appear to have been adapted to both ground and tree life. They display relatively elongated legs and arms shorter than their torso, which was a first. They also had an elongated brain case, showing us that they may have been one of the first hominids to begin specializing in brain size. Oh, and they were also the first to control fire. Pretty big deal. Interestingly, some scientists suggest that Homo erectus began cooking meats with fire, which made them easier to digest, brought out some nutrients, which led to larger brain sizes. Bing bang boom, you got a big noggin. Homo erectus really kind of was the first human. They were the first to truly separate themselves from other apes. From here, I'd like to discuss some other things that really set humans apart from everyone else. Take a look at this guy. Pretty cool. That's a California quail. Compared to the perfection that is the California quail, you might look a little funny. Another example, here's a gorilla, aka gorilla. And then there's you. A little more similar, still kind of funny looking. So what really separates humans from not only other apes, but also the rest of animal slash plant slash prokaryote slash bacteria kind? Well, way too much stuff to talk about in just this video, but here's some interesting examples. Our mating patterns. This one is gonna get a little bit graphic, I'm sorry. So, mating. Nothing's cooler? Every person that exists came about because a man and a woman loved each other very much, and did some stuff. This is also true of every other ape species. Courtship is very important in this process, but apes and humans do it very differently. This is an example brought up in Sang-Hee Lee's book, Close Encounters with Humankind. Really nice read, you should definitely read it. Chapter 3, The Birth of Fatherhood. She gives us 3 examples of courtship methods in chimps, gorillas, and humans. I'm about to go into my Austin in biology mode. So, gorilla females generally go into estrus, or heat, at the same time. Because of this, gorilla males need to compete with one another to gain access to females and to protect their chosen mate. If we look at female and male gorillas, we can see a large difference in size, known as sexual dimorphism. Gorillas have evolved larger and larger body and canine sizes in order to compete and establish themselves in the social hierarchy. The larger gorillas often compete with moderate-sized gorillas for mates, which interestingly sometimes lets lower-level gorillas come in and swoop the girl. So for gorillas, size equals better chances for a mate and passing on your genes. Chimpanzees, on the other hand, have developed a different, much more disgustingly graphic method of courtship. The size difference between male and female chimps is not very obvious, because they do not need size to compete with other males for a mate. Unlike gorillas, female chimps do not go into estrus at the same time. So instead of there being a mating period, male chimps essentially go around and mate with as many females as possible. So what methods have chimps evolved to ensure that their sperm impregnates a female? They have giant nuts. Sorry. Larger testicles equal more sperm, and since all males mate with as many females as possible, larger testicles raise their chance of impregnating those females instead of any other males. So if you ever look at a picture of a chimp and feel a little intimidated, now you know why. So what does this information have to do with humans? Well, humans don't really compete for mates through size or size. In fact, humans don't really compete for mates at all. And this is because humans have developed the monogamous relationship. Sang-Hee Lee says this: "Neither of the mating strategies adopted by gorillas and chimpanzees give males a clear sense of paternity. Therefore, it makes sense for males to concentrate their efforts on making babies and invest no effort in raising them. Indeed, that's what we see. No male apes raise babies, and chimpanzees thus don't have the experience of being raised by a father." She then goes on to explain how humans have taken a different approach. Human males focus on childcare. To explain further, imagine you're a Homo neanderthalis female who just had a baby. You're going to need to spend time carrying that baby, breastfeeding that baby, etc. You're pretty limited on what you can do, but males aren't. They can go out, hunt, forage, whatever. Males are likely to go out of their way to provide resources for those females who are in estrus. But there's a fancy little trick that human females have developed: ovulation suppression. Unlike gorillas and chimps who openly display that they're going to ovulate very soon, humans suppress it in order to make males provide for them continuously, because a male will do so if there's a chance that the female carries his genes. Since ovulation tests weren't really around back in the day, there was no real way for a male to know if a female was ovulating, so thus they continuously provided, creating the monogamous relationship. And the result of this? Humans have sex, like me, a lot. The monogamous relationship has led to human children having much higher chances of survival compared to other ape species. That's pretty cool. A little disgusting, but pretty cool. Brain size. So, brains. They're weird and confuse me, but they're important. Humans have separated themselves from other animals by specializing in brain size. Like I mentioned earlier when discussing Homo erectus, brain size began to increase drastically with them for many reasons. Over the past 2 million years, the human brain has tripled in size. Australopithecus afarensis was the first to begin to differentiate themselves from other apes by developing a skull size of around 400 to 550 milliliters, with notable changes in the neocortex, developing other sections of the brain while taking away from visual processing. Watch Vsauce's video on the cognitive trade-off hypothesis if you want more information on this. It's super interesting. Later on, Homo habilis took a small jump in brain size, while also developing the language center called Broca's area. By the time Homo erectus came around, the volume of the human brain case was up to 600 milliliters. And then by the time that us, Homo sapiens, came around, the brain case had evolved to around 1200 milliliters. Our brains have developed significantly in areas dealing with cognition, solving complex problems, planning, communication, and many others. As culture came around, as well as agriculture, our brains did shrink a little bit, but our brains are still massive and among the largest compared to our body size in the animal kingdom. This actually brings me into our final section. Our bodies suck. If you exist, you probably have pain somewhere. It's pretty common knowledge that humans have evolved in ways that benefit us tremendously, but also negatively affect us. But I think the most important aspect to mention is bipedalism and its effect on childbirth. Everybody knows that childbirth is kind of the worst thing in the world, and we have our human ancestors to blame. As our ancestors developed walking upright, or bipedalism, we modified our pelvises to become narrower, which, incidentally, in combination with our ever-enlarging head sizes, created a painful, sometimes deadly experience for females giving birth. Something interesting, this mostly started in, you guessed it, Homo erectus, who I will be blaming for all of our problems from now on. This is another aspect detailed in Close Encounters with Humankind. Sang-Hee Lee explains how this evolutionary difficulty in childbirth may have created more communal bonding in humans. Now I have to go into Austin and gynecology mode. So basically in every mammal that gives live birth, the baby has a pretty easy time passing through the birth canal on its way out. Basically, slip, amen. In other ape species like chimps, as they're giving birth, they grab the baby and pull it out of themselves. The baby comes out facing the same way as the mother. The mother immediately supports its head and looks into its eyes. Yes, I watched a video for this explanation, and I am still incredibly haunted by it. It was the worst thing I've ever seen. Since humans are evolutionarily challenged, it doesn't work like this for us. Since the baby's head is so massive compared to the birth canal, the baby needs to spin around a couple times in there. When the baby finally makes its way out, which can take a really, really long time, as my mother likes to remind me all the time, it's facing the opposite way of the mother. So what's the problem? Well, our arms aren't as long as chimps, so we aren't able to reach down and grab the baby and support its head. In order to make sure the baby comes out okay, we need some help. Starting around the time of Homo erectus, communal births began to become more common. Other ape species usually give birth alone, but our difficulty in childbirth required the help of other females. Sang-Hee Lee explains how other females became essentially the first midwives and doulas, helping the baby come out and making sure that its head is supported. In combination with the monogamous relationship, communal bonding in childbirth like this likely led to a much higher survival rate for human babies. Take that, bipedalism, you dick. We have a lot of other common problems. Back pain, our feet have way too many bones in them. We have organs that don't really even do much and then get inflamed and explode. Many more. Our evolution was so quick, we didn't really even have time to catch up with ourselves. So all these things that I've discussed, our ancestors, mating patterns, brain sizes, our bodies sucking, they're all essential to the human story. In terms of the animal kingdom, we aren't special. All these problems aren't what make humans special. It's what makes them weird. I hope you enjoyed this video. I had a lot of fun learning about all this stuff, and it makes me absolutely hate Homo erectus now. I hope you like this direction I'm going to take with my channel. I've been thinking about doing more anthropology, archaeology things. But if there's anything you would like to see me cover, just let me know down in the comments. Thank you so much for watching, and I hope you have a lovely day. See ya.